There we go.
Red button pushed.
All right, so basically we were just talking about the idea of water, all right? What does water look like? What's its shape?
Who knows?
It's bent, all right? If you remember anything from this, you may or may not, but oxygen, how many electron dots does oxygen get if you look at the periodic table?
6.
Gets 6, all right? And so that means it's got 2 pair and 2 spaces. This, if you don't remember this, it's okay, we'll come back to it. This is just the basics. All right, hydrogen has its 1 electron, comes in like that, comes in like that, all right? It gives it this bent shape. That's huge, hugely important, because we were just talking about dissolving ionic things. The only way water is going to be able to dissolve ionic things is if it has some positive and negativeness to it. Does that make sense? Okay, so how does it have positive and negativeness to it? If you'll remember, we were talking about the 3 types of bonds. We have ionic, covalent, and what's the middle one? Polar covalent. All right, polar covalent. Now, that's when they share unequally. Which do you suppose is the stronger based on what we've already said? No, I mean in terms of oxygen or hydrogen?
Oxygen.
Oxygen. So what's going to happen is the electrons in this bond are going to spend a little more time over with the oxygen than they are with the hydrogen. All right? And similarly in this bond, a little more time with the oxygen than the hydrogen. That means that this is going to be slightly positive-ish, and this is going to be slightly negative-ish. All right? What they say in fancy terms is dipole positive and dipole negative. All right? And what they use, the symbol is a lowercase Greek d. So for delta. All right? So what does that mean? That means that this side of the molecule, the oxygen side, is a little bit negative. The hydrogen side's a little bit positive. So what's that mean in terms of if I throw some salt in the water? If I throw some salt in water, sodium is what charge, everybody?
Positive 1.
Positive 1. It's over on that end.
Positive.
And chlorine is negative 1. So what happens is, in comes a water, and the water is attracted in different ways to different things. The sodium is attracted by the oxygen, because the oxygen is negative-ish, dipole negative. And so the oxygens kind of come in and surround the sodium and pull it away. Similarly, what do you suppose is attracted to the chlorine? The hydrogen ends. All right, so the hydrogen, the positive end, is attracted to chlorine, and so it effectively grabs them, stretches them, pulls them apart. That's how it dissolves ionic things. So that's what's going on with dissolving. The idea is that the polarness of the water allows it to rip apart sodium and chlorine ions. And you know that salt is fairly soluble, right? It dissolves fairly easily in water. So, can we get to a point where salt won't dissolve? Can I throw enough salt in water that it won't dissolve?
Yeah.
Sure. All right? Because so many of these oxygens and hydrogens of the waters are already holding on to a sodium and a chlorine that just can't take anymore. Does that make sense? Okay? So the idea is that this is a polar covalent molecule with polar covalent bonds. We'll come back to that later, so don't panic. All right? And the polarness is what allows it to do what it's doing here. That's why salt water. That's why you exist. You know, if it weren't for the fact that water is a polar molecule, we wouldn't be here. Does that make sense?
Chemistry, not philosophy.